Hi everyone, my name is Owen Law. I'm a Telco Solutions Architect from AWS. Today we're going to show you a very unique collaboration between Starhub, Singapore University of Technology and Design, and Syndesigntek. Our focus is how we can leverage generative AI to build a network operations framework to power Open RAN network operations. In this collaboration, we're trying to solve unique challenges from each of the participating entities. For Starhub, which is a leading telco in Singapore, they have traditional radio network access network, and they're also looking to adopt new technologies such as Open RAN. When they introduce new vendors from Open RAN, one of the challenges they face is they need to bring in new types of network data, new types of processing and analytics capabilities. For SUTD, the Singapore University Technology and Design, they operate one of the leading research and interworking environment for Open RAN and AI RAN in Asia. So dealing with the complexity of integrating Open RAN components from different vendors is a day-to-day challenge for them. And for Syndesigntek, their focus is the Open RAN solution components like the CU, DU, and RU. For them, the ability to plug their solutions into a very lightweight, cost-effective network operation framework, it's very important. This is the collaboration and the joint solution which we have built for this demo. So we have a multi-vendor, multi-cell setup in the SUTD campus environment using Open RAN technologies. This campus setup is interconnected with the Starhub mobile network core, and we also built an integration with the Starhub network API platform. As you can see, we also leverage simulator from VRV to generate some of the baseline traffic. Our focus for this collaboration is in the top layer. This is where we overlay a generative AI-powered platform using agentic workflows to drive network operations tasks across different stages, from capacity planning to applying network configuration changes to the network, to troubleshoot complex network issues, and also to deal with specific customer experience challenges. Our focus is more on creating this network operation framework that can be applied to any type of Open RAN or even traditional RAN environments. We're integrating this, through Open API interface, and as the middle layer, which is the service management and orchestration and real-time and non-real-time controller platforms evolve their capabilities, we'll be able to leverage more of the capabilities going forward. So let me tell you a few things unique from an AWS perspective before I jump into the demo. So here, the first thing I want to bring to your attention is the data analytics pipeline. In order for us to support this multi-vendor, multi-format Open RAN setup, we build a unified data ingestion pipeline, which allows us to take all kinds of data, including performance management, fault management, configuration management, ingest it into AWS using AWS native services such as Glue, Antenna. And once we have this data ingested, this foundation allows us to derive insights from the data. The second part is the network analytics insights. So for the network analytics insight, these are extracted from the foundation data, extracted from the Open RAN network. And we will be able to use this insight into a network knowledge base. We can also build capabilities like machine learning and anomaly detection to identify unusual patterns happening in the network. A key innovation we have built in this collaboration is this multi-Gen AI agent collaboration framework. As you can see, we have multiple Gen AI agents collaborating with each other. We equip each of these agents with different tools. Example of these tools will be like a text-to-SQL tool, which allows to query metrics directly from the network. We also have tools such as this ORAN API tool, which allow us to interact with the network directly to apply network configuration changes. As you can see on the diagram, we have also worked with SUTD team to build an API abstraction layer. This abstraction layer helps us supplement existing SMO capabilities in order for us to apply network configuration changes to the CU and the DU. Other examples of these tools will include the ability to invoke anomaly predictor machine learning endpoints. You will see in the demo, any changes we apply to the network will not happen without a human approval. That's why we have a human approval tool shown here. Finally, there's also one more tool which we have built, is the Network API tool for integrating with the Starhub Network API platform. Throughout the MWC exhibit, you would hear a lot about GSMA Camara API, mainly for external monetization purpose. In this demo, you will see how we can also use Camara Network APIs for network operation use case. So this is the demo platform which we have built. Our focus is to build a proactive network operation experience. When you think of Gen AI agent, most people will thought of a traditional chatbot, style interaction where you ask the chatbot some questions, it will reply with some answers. However, when we talk to network operators and network admins, their feedback is they want something more proactive. So what you can see from this dashboard is it basically provide notifications as new incident, new events happen in the network. By the time you see a notification pop up, the generative AI agent would have already performed its task in the background. So the first use case we're showing is a cell overcapacity use case. In this scenario, we detected that one of the cells in the network is approaching capacity limit. As you can see, once we click on the incident, the generative AI agent already did the correlation in the backend to identify what could be a root cause of this issue and suggest one way to fix the issue is to turn on a capacity cell in the network. It will also provide a recommendation of what changes needs to be applied in the network. So you can see the configuration snapshot here. If the network admin wants additional information, it can pull up the optional chatbot on the right to understand a little bit more about the problem and the recommendation. But this is more of a supplementary function. The main function is proactively happening with the agent in the background. As you can see, the network changes will not be applied until there's a human approval in the loop. So in this example, once the capacity cell is turned on, we have additional capacity in the network. We can also apply this framework to more complex use case, such as a handover issue. In SUTD campus, as you see, there's multiple cells. As initially this cell is not configured correctly, as user goes through the cell, we see an excessive amount of handover happening. Using the same agentic framework, the agent is able to detect that there's an issue with the handover configuration and suggest what changes needs to be applied to, such as an A3 parameter change to address the problem. We can also apply the same ability into network configuration. So here's a very simple example of a user initially mapped to an incorrect network slice. That's why the user is suffering from poor video performance. Again, the agent recommends the correct network slice mapping. And what you can see is a comparison between users now being mapped to the correct slice on the left and existing user that has suboptimal experience in a shared cell on the right. The last use case we'll show is integration with Network API. So in this example, we have a user basically reporting an experience issue, but for whatever reason, the user's exact location was not captured. What we can do is, again, leverage the agentic backend to make an API query to Network API endpoint. And we use this API to verify the user's exact location to check that they're within the SUTD campus environment before we proceed to further troubleshooting. In summary, we deliver three very tangible outcomes for the participating companies. First one is we created this unified Gen AI-powered Open RAN network platform, which is something that can be leveraged by the SUTD team in their own environment going forward. For both SUTD and Starhub, this collaboration basically gives them a foundation to build upon. From a Starhub perspective, they are able to leverage this framework and potentially reuse for other enterprise customers. And finally, one of the really tangible outcomes is by using this agentic framework, we significantly reduce the time to identify root cause in the campus network and provide a resolution. We bring down that troubleshooting resolution time from weeks to minutes. That's a summary of our demo. Thank you very much.